Hello guys, welcome guys, and we will be discussing past year ISI MStat problems as usual, where we will be understanding and discussing the probabilistic aspects of the problems, the probability problems rather. Yeah, so let's get started, guys, and let's get started. Okay, so Sneha, what we have done till the last day? Can you tell me once which question we are left? I think we have done 24, 22, okay, 22, and let's check what else we have done. So yeah, till 19 we have 2020, yeah. So we have done till 19th problem, and we'll be discussing the rest of the problems today, and also ISI MStat 2019 ka. So this is a problem for 20th problem of 2020. Let's do it, okay? Let's do it, guys. And okay, so let's start. The moment generating function of a continuous random variable is given by mt is equal to e to the power t into t plus 1, where t is between, if it is a real number, okay? And phi denotes the cumulative distribution function of standard normal variable. What is probability of x greater than 0? Okay, let's try it out. Let's try it out. Any ideas, Sneha and others, on how to approach this problem? We want to find probability x greater than 0. So कुछ तो normal के साथ relationship है, right? So do you remember the moment generating function of normal? Normal mu comma sigma square. What is the moment generating function? Do you remember, guys?
E to the power mu t plus half t square sigma square.
Mu t plus half t square sigma square. Okay, lovely. And from here, can you tell me, like, yeah, here it is equal to exponential t plus t square. So x follows what normal?
1, 2.
1, 2. Lovely. X follows normal 1, 2. Very good. And okay, so let's observe that if x follows normal x 1, 2, so probability x greater than 0 is same as what? Is same as probability. We need to standardize it because the given is in terms of, so 1 minus this by root 2, right? Then x, this follows, then x minus 1 by root 2 follows normal 0, 1, right? The standard normal. So this is equal to minus 1 by root 2. So it's equal to 1 minus probability x less than 1 by root 2. Okay. So can you tell me, like, if probability, okay, let's not do like this. Let's do like, it's equal to z, probability of z greater than equal to minus 1 by root 2. Okay. So what is the probability? Can you tell me, guys? Let's see what are the options. The options are
number C.
Okay, number C. Why? Because you understand, if you draw the diagram, minus root 2 से ज़्यादा, okay, is same as 1 by root 2 से कम. Like this area is same as this blue area, right? The red area is same as the blue area by the symmetricity of this. So therefore it's equal to phi of 1 by root 2. Very simple problem. Okay, very simple problem. And let's move to the next problem, guys. Let's move to the next problem. Any doubts in this problem, guys? It's a very simple problem. So we have, last day we have done till 19th. The probability problems. Let's do 21st problem. What does 21st problem say? 21st problem says that, let me copy and paste the problem over here. 21 problem says the following. Let me, 21 problem says the following, that in a multiple choice question test, multiple choice tests uses the following scoring procedure to discourage the students from guessing. Okay, let's check it out. So ISI MStat 2020, problem number 21. To discourage students from guessing. For each correct response, the score is 5. For each incorrect response, the score is 0. And for no response, the score is 2. If there are 4 choices for each question, what is the minimum number of incorrect choices a student must eliminate before it is advantageous to guess among the rest than leave the question unanswered? Okay, so I will discuss this problem today, and the same problem has been given in the LinkedIn problem list today. So I want all of you guys to go on to LinkedIn after this class and write down the problem properly, so that as if it's a PSB problem, and post it there, okay, so that we can check your solution. Okay, that is a request and that is a master actually, so that we can check your solution. And you can also encourage other students with your actual solutions. Okay, let's come back here. That a multiple choice test uses the following. Okay, so correct ke liye, let's see. For correct, we have +5. For no response, draw. For winning, +5 for draw, plus true. For losing, 0. Okay, that's a really interesting way. You understand? This is a really interesting way. Draw, if a person doesn't know something, then the person will do draw, right? More. This is a really interesting scoring procedure. Okay, so if there are 4 choices for each question, what is the minimum number of incorrect choices? It's a multiple choice, okay? So incorrect choice the student must eliminate, so that it's advantageous to guess among the rest than leave the question unanswered.
Can I answer?
Sure, tell me your ideas. It's a beautiful question.
First, we'll take the case 1, eliminating 0 choices. So probability of going wrong will be 1 by 4. Then we will find the marks that will be obtained per question. That will be 3 by 4 into 0 plus 5 by 4 is equal to 5 by 4. Then we will eliminate 1 choice. Then the question to go wrong, the probability will be.
No, but I'm not understanding. Wait, I'm not understanding. So you are telling, let's say, if there are 4 choices, what is the minimum number of incorrect choices the student must eliminate?
Suppose we eliminate 0 choices.
Okay, that means okay, then, perfect.
Then the probability of going wrong will be 3 by 4, and, and going correct will be 1 by 4.
Okay, perfect.
So marks obtained per question will be 3 by 4 into 0 plus 5 by 4, that is equal to 5 by 4.
Marks on obtained. Okay.
Then second case, we are eliminating. Now the probability of going wrong will be 2 by 3 and going correct will be 1 by 3. And so marks obtained per question in this case will be 5 by 3. Similarly, when we eliminate 2 choices, we will get the probability of going wrong will be half and going correct will be half. And marks obtained in this case will be 5 by 2. So the marks, the case where we are getting more marks, then we will eliminate 2 choices. So, see.
Okay, let's check it out. So what Sneha told is interesting. So by the way, so there are 2 such questions that I observed in this paper, which is open-ended in the sense, in that previous question about that rat wala example, and this question, it's like it's a open-ended question, okay, in the sense that it's not defined what to do. You have to define what to do. So here it's told that it's advantageous. So what is the mathematical format, mathematical definition of advantages over here, guys? The mathematical definition of advantages over here is the expected number of average values, right, guys? Okay, right, Sneha? That's what you mean, right?
Yes.
So it's the average number of, it's the expected value. Okay, expected marks rather. So we have to compare expected marks in each case. Expected marks. Okay. So let's see. Therefore, the marks follow. It's a random. Okay, it's a question is random. So the person doesn't know the solution, right? If the person knows solution, that's done. So here, and let's say initially, so question unanswered, right? So question unanswered. If the person left the question unanswered, then that person gets +2 marks, right? The person gets +2 marks, right? But here, let's say the person is answering, so he must be either correct or incorrect, right? So we have to select that choice such that the average. So here it's a Bernoulli sort of idea. Okay, it's a Bernoulli. So the number of marks over here follows Bernoulli something. Let's understand what is Bernoulli. If you get correct, it's +5, right? If you get incorrect, it's 0. So it's M by 5 follows Bernoulli P. Now this P is different for different cases, right? So M is the random. So I am defining it in this way because we need to know what we are doing. So so we need to be like when you write in PSB, you have to write in this way. That's why I'm just discussing PSA in terms of PSB. Same with the random variable, which is correct and incorrect. So for correct, we get +5 marks. For incorrect, we get 0 marks. Same by 5 follows Bernoulli P, right? M by 5 follows Bernoulli P. Okay, so now what we need to find is expected value of M in 3 different case scenario. So if the question, what the 4 cases are the following: that we need to eliminate choice. If we eliminate 0 out of 4 choices, that means M by 5 follows Bernoulli. P is a probability of success. So P is equal to 1 by 4 because only one choice is correct, right? So what is the expected value of M over here? Expected value of M is NP. Okay. So N number. So let's do it for 1 because it will be just proportional. So here expected value is P, so it will be 5 by 4. ठीक है? 2 के लिए eliminate 1 by 4 choices, like 1 out of 4 choices. If we eliminate 1 out of 4 choices, M by 5, so we have eliminated. That means we know that one option is incorrect. So therefore, probability of success is 1 by 3. One option out of the other 3 options are correct. So expected value of M is therefore 5 by 3. Right? Sneha, are you understanding? Others, are you understanding, guys? Kartikya, are you understanding? Bhushan, are you understanding? Okay, lovely. So now understand that if we eliminate 2 choices now, so P is becoming half. Okay. So we have expected value of M is equal to 5 by 2. That is 2.5. It's greater than 2. Here is less than 2. Now if we eliminate 3 choices, what will happen? What will happen if we eliminate 3 choices? Sneha?
Then the leftovers will be the correct. That means we know the answer.
That means we know the answer.
Then it will not be guessing anymore.
That will not be guessing anymore. So if a person is eliminating 3 choices, okay, then that person is not guessing anymore. So that's the idea. Okay, that's a very simple idea. Perfect. So understand this. So these are the very subtle ideas. So people, if you go by the method, it will be what? It will be 1 by 1, that is 5. So people will mark this, but it is not guessing. Okay, it is not guessing in some sense. So therefore, two choices are important, and it's like people, the person doesn't know the solution. So that is the basic idea. So make sure you don't mark 3, that mark 2. Okay, that's the idea. So therefore, you can understand. Therefore, it's greater than 2, and more marks will be got over here. So you can easily understand. The more you guess, the more you eliminate, the more you get the better answer. So elimination is a very good choice for problem solving in PSA. Okay, so it increases your marks. So make sure you follow this method. So now your homework is to find out if the values are A, B, and C, then what will happen? Okay, if the values are A, B, and C, then understand that which is the best, like how many answers to guess. Of course, 3 nahi, so you have to just do it for 1, 2, and 0, 1, and 2. Okay, 0, 1, and 2. So understand that which for which cases it will be much more. So just do the general problem. Okay, in fact, do your ISI problem. ISI के लिए 4, 2, and 4, 1, and 0 होता है ना, right? Sneha, is it 4, 1, and 0 for ISI? If it's 4, 1, and 0, you can easily understand that. You can easily understand that 4 by. So unanswered is 1. So you can easily understand, but just if you eliminate one guess, if you eliminate one option, it will be 4 by 3 only. Okay, so it is always good to eliminate rather than like doing it. So this is the basic idea. Okay, so this is the basic mathematics behind it. So do it, guys, as a homework. Okay, for the ISI exam. Oh, sure, Bhushan. M by 5 is born only because M is what? M is plus 5 if success, 0 if failure, right, Bhushan? So M by 5 is 1 if success and 0 if failure. So M by 5 is Bernoulli. Did you understand? Bernoulli P. Did you understand now, Bhushan? Okay, perfect. Okay, lovely. Let's move on to the next problem, guys. Let's move on to the next problem. Let's do it. Let's do the problem. 21 is done. Okay, we are on 22. Let's do problem 23. Problem 23. It's a conditional distribution problem, as far as I can see. Okay, suppose x follows binomial 3, 2 by 3. So, and the conditional distribution of y given x is normal x, x square plus 1. Okay, so y given x is equal to x follows normal x, x square plus 1. Okay, so it's given the conditional distribution of y given x equal to x follows normal x, x square plus 1. Here also ISI made a mistake. I don't know how did we discussed about this issue. ISI made a mistake over here. I don't know why, but anyways, so then the variance of y is what? X follows binomial 3, 2 by 3. You can understand that PSF problems are much more of basic nature, the basic understanding, whether you know conditional distribution, whether you know law of total, like Adam's law. What is Adam's law over here? It's like smoothing property. Okay, you need to find out variance of y. So how do you find out variance of y? The variance, you can understand, like the PSF part of ISI is really not hard. Okay, you have to just apply the basic methods, guys. Okay, it's easier than IIT like objective paper. You just basically test your knowledges. I hope that's what you think. What do you think, Sneha? Isn't it that true? Sneha, Kartika, Bhushan, I think these problems are much more Easy.
Yes, sir.
So they're easier than ISI, IIT, JAM, whole thing. But the PSB will actually test your metal. Okay. So we will discuss a few PSB problems today also. So variance of y is what? Variance of expectation of y given x plus expectation of variance of y given x. Okay? Expectation of variance of y given x. So think about it. Think about it now. What is the variance of y given x? Variance of y given x is what? X squared plus 1. So the expectation of y given x is what? X. You can easily understand. Variance of x plus expectation of variance of y given x. So y given x is x squared plus 1. So therefore y given x is equal to capital X squared plus 1. Variance uska. Okay? And therefore we get that it's equal to variance of twice. So it's no, understand the variance of x plus expectation of x square. Expression of x square is variance of x plus expression of, so it's like this, plus expectation of x whole square plus 1. It is twice variance of x. So x is binomial n comma p. So it's n comma p into 1 minus p. So twice into, what is n over here, Sneha? What is n over here, Sneha? In your 3 and p is
2 by 3.
So it's 2 by 3 into 2 by 3 into 1 by 3, n into p minus 1 minus p. Plus expression of x is np, so it's 3 into 2 by 3 whole square plus 1. So let's check it out what it is. It's equal to 4 by 3 plus 4 plus 5 plus 5. So is this such a solution? 19 by 3 is the solution. Is it A, guys? Yes, okay, perfect. Let's move to the next problem. It's a very easy problem, guys. Let's move to the next problem. Okay, I have discussed 29 also. So let's discuss 27 also I have discussed. So only problem that is 24. Let's discuss 24. We'll then move on to PSB. Guys, do you have any PSB doubts, guys, on probability? Suppose x and y are independent observations from normal 0, 1. For t greater than 0, we define gt to be this. Okay. Given x plus y is greater than t. Given x plus y is greater than t. So how you can then you have to understand what is g. Okay. How is the property of g? Okay. So one thing you should observe over here that x and y, x plus y, x minus y have good like distributional properties since it's normal. So x plus y follows normal 0, 2 because they're independent. Okay. And x minus y also follows normal 0, 2. But they are dependent. X minus y and x plus y are dependent upon each other. Okay. So how do you understand this?
No, x plus y and x minus y are independent of each other.
How?
Covariance between x plus y and x minus y. Expectation of x plus y into x minus y.
Okay, it's coming out to be independent. Okay, in this case it can be independent, but in general it's not true. Okay. Let me check it out. No, but covariance doesn't mean it's linearly independent. It's come. Okay. I see. Okay, I see now what you're telling. Let's calculate. So there is an idea I will tell you. So in case of normal case, the result if two normal random variables u and v are independent and normal, that means they are like it's even only if they are not correlated. Yeah, we are right. We can also show it by this result that u and v, if their covariance is 0, if two normal random variables the covariance is 0, okay, Obhirup and others who are here, then they are independent. But in general, this is not true, okay? In general, this is not true. Let's check it out. Covariance of x plus y is now it's covariance of x comma x plus covariance of y comma x minus covariance of x comma y. Am I doing it correctly? Minus covariance of y. Am I doing it correctly? Asneha and others who are here. Okay, so we are seeing that this is variance of x minus variance of y. If x and y are similarly distributed, then that's therefore 0. Okay, so they are non-correlated and therefore hence they are independent. Perfect. Very interesting property. So that's a very good idea, and therefore you find out that this is equal to probability modulus of, oh, by the way, there's a modulus over here. Did you check that? Oh, modulus will not matter. Do you know why? Modulus will not matter because if two variables z and w are independent, then any function of z and any function of w are also independent. So therefore, modulus of x plus y, x minus y is greater than t. This will be the same thing, right? The probability will be the same thing as this, so which will be probability of x minus y greater than t or x minus y less than minus t. Okay, this is same as probability of x minus y greater than t plus probability of x minus y less than minus t. We will again use the symmetricity of the random variables. Probability x minus y is greater than t, and here understand it's same as probability y minus x is greater than t, right? And y minus x distributed is same as x minus y because they are independent, like non-independent, sorry, because their mean is 0 and you can easily prove that. So it's twice of probability x minus y greater than t. Okay, and it's therefore twice into 1 minus 5, like not 5 but yeah, you can understand 1 minus f, a distribution function f of t. Now distribution function is what? Is increasing, like it's not decreasing, and therefore here minus, since it's a continuous, it will be increasing over here, and therefore it's decreasing over here, therefore it's decreasing. The answer is coming out to decreasing, Sneha and others. So Abhirup, yeah, it can also be shown by independent by orthogonal transformation. You're right. Yeah, you're right. Yeah, perfect. So we have completed all the probability problems of 2020 paper. Let's move on to 2019 paper, and I will discuss one problem from PSB. I have just rubbed the PSB problem. That's bad. ISI 2020. Let's check it out if I can find out. In the meantime, PSB loads. I will start solving the 19th problem, 19 paper. Okay, I will start solving the 19th paper, and let's check it out. Let's check out the 19th paper. Okay, any doubts in 19th paper, guys? Otherwise, I will move on to some other problem like not other problem, but I will move in the general flow. Any doubts from 19th paper? Sneha, Bhushan, Kartikya, and all others who are here, also in the live. Any doubts in the 19th paper of ISI MStat? Yeah, bolo. Otherwise, I will move naturally. Yet attempt?
Thirteen.
13. Okay. Is it a probability problem?
Oh no.
Oh, please tell me a probability problem. I will be coming to other problems also. Don't worry. Other high school mathematics and other problems.
No, then I don't have any job.
Okay, then help me out in solving the problems quickly for the students. Okay, so let's check it out. We are starting the first probability problem from 18th. Okay. 18th problem is the first probability problem. There are a lot of mathematics problem. So make sure you're good in mathematics. Okay, for ISI MStat. 18th problem. What is happening? Please, what is happening? Just give me a minute. My laptop. Someone needs to donate me a laptop. Draw observation n at random from the set 1, 2, 3, 5, 100. Okay, so what is the probability? Last digit of n square is 1. Oh, 1920, I didn't see it, Bhushan. Sorry. Let me do it and then I will go to 1920. Okay, Bhushan. So draw an observation from the set 1 to the power of 10, 100. What is the probability? Last digit of n square is 1. Tell me, it's very easy, guys. Just classical probability. So just check out for Jiska square is ends with 1. So which number ends with 1? Which one? 1? Bolo.
And 9.
1 and 9, right?
Yeah, the unit place must be 1 and 9.
Yeah. Perfect. Thank you. So yeah, so let's check it out now. Understand that we don't have to count all the 9 digits. You just understand till 1 to 10, okay, and 2 to 10. Okay. There is 1 over here and 9 over here. Similarly, for all of them, 11 to 10, 11, 20. So in each 10 interval, how many numbers are there? Jiska square is 1. Each interval, how many numbers are there? Jiska square is 1. Tell me, in each 1 to 10, 11, 20, how many numbers are there? Jiska square is 1. In each interval, 2. So 2 numbers, and each interval it's 2 numbers, right? And therefore, it's 2 by 10. Because it's in each interval it's behaving similarly. So it's 2 by 10. So 1 by 5. Instead of counting 2 into 10 by 10 into 10, we are counting 2 by 10 because it's uniformly behaving in each of the places. Okay? Perfect. I hope you understood the idea. It's a very basic idea, but it's the classical probability problem. Perfect. Let's move on to problem 19th. Nice, rain is coming. Oops. Perfect. Let's try it out. The 19th of ISI MStat 2019. So X is the number of tosses of a fair coin required to get the first head. If Y given X is equal to N is distributed as binomial N comma half, then what is probability Y is equal to 1? Very simple. Very simple. Can you tell me how you will do it?
Probability X equal to X will be half
Probability X is equal to X
into half to the power X minus 1.
No,
and X will run from
wait,
1 to infinity. 1, 2, 3, 4.
Okay. So what theorem you are using? What result you are using? Because you have to write that result
Geometric. X follows geometric P. And X is following geometric distribution.
X is following geometric distribution, but I'm just telling you that you are telling the So what I'm telling you is the following: that X follows it as geometrically. That's true. But my question is that probability Y is equal to 1, you're doing like this, right? Summation of probability Y is equal to 1 given X is equal to N, right? Into probability of X is equal to N. You're doing like this?
Yes, I did like that.
So what is this result?
Okay. It is X equal to Y.
No, what is this result called?
Oh, this is law of total probability.
Yes, law of total probability, exactly. So you have to use the law of total probability. Perfect. You're right. So you're getting this, and we know individual distributions. The idea is very simple. How do you understand law? You have to use conditional probability because you are conditioning on some stuff. Okay, that's the idea. So you get now Y is equal to 1 given X is equal to N is what? So Y given X equal to N follows binomial N comma half. So here it will be Y given X is equal to N follows binomial N comma half. So here it will be N choose 1 into half to the power N, right? Into probability X is equal to N, X is equal to X follows geometric, right? So it's the number of fair tosses required to get to the first head. If it's 1, if it's N tosses are required, so it's P into 1 minus this half into 1 into half into 1 minus half to the power N minus 1. So it's actually half to the power N. So it's summation N is equal to 1 to 100 N times N by 2 to the power 2N. This is what is coming, Sneha and others. Bhushan, Kartika, is this what is coming? Perfect. So what do we get now? We use it by AGM series. So if this is S, then we find out 4S. So you can sort of understand it's summation of N to 1 to infinity N by 4 to the power N. So 4, that's why I multiplied by 4S. So it turns out to be 4S means turns out to be summation N from 2 to infinity let me check. Not 2 to infinity. So you can write it as like this. I will just write it in a normal format. So 1 by 4 plus 2 by 4 square plus 3 by 4 cube ऐसा. और नीचे वाला 4s आ रहा है 2 by 1 by 4 sorry 4s that's coming out to be 1 plus 2 by 4 plus 3 by 4 square plus dot ऐसा ही. So if you do 3s, if you subtract this from this, so you get 4s minus s is you get 3 by 4 plus, sorry, not 3 by 4, 1 plus 1 by 4 plus 1 by 4 square plus dot aisa. So therefore you get that 3s is equal to this sum, which is 1 by 1 minus 1 by 4, which is 4 by 3, right? So therefore S is equal to 4 by 9. Am I correct? Is it correct, guys? The solution 4 by 9 option है कुछ bah there is an option, so it's option A. Perfect. Let's move to the did you understand, Bhushan? Let's do the 20th problem. From next day we will be starting the statistics discussion, guys. Okay. Yeah, and we're also planning to start a crash course on inference and probability. Let's see how many people join the crash course for 1 month or so. It will be available to you, all those are enrolled in the program. That's not a problem. That's really for external people, because many people have asked me to do this. Let's check it out, how it happens. Okay, probability. Suppose X. This is the 20th problem. Suppose X is uniformly distributed. X is uniformly distributed. So make this habit of writing down properly, okay, so that your PSD automatically gets enhanced. X follows uniform -1, 1. Let Pi is equal to probability X square is between I by 4 and I plus 4. Okay, this is an interesting problem. So when you understand this X square is this, you have to transform it to X somehow. Don't think of always Jacobian, okay, or those results like this. Understand, do it naturally. If this is the truth, then this how can Pi be distributed? It can be distributed in two ways. That means if X square is between I plus 1 by 4 to I by 4, then X is between what? Not always, don't think about Jacobian, okay? Think in easier way, guys. Very easy ways. Think about in normal mathematical ways. I believe any person who is done very good, not good, but he's confident in basic probability and statistics, guys, I'm sure that person will get through PSA very easily. Very easily.
Probability minus half less than X less than 0 plus probability 0 less than X less than half.
Perfect. So you get to half कहाँ से आ रहा है? I है ना?
So I've calculated for 0, 1, 2. No, yeah, I plus 1 by.
Okay, she has done. I will tell you. She has done option matching. I'm doing it in general. So it will be. Oh, it will not root 2 but 2. I just doing square root. Okay. So my handwriting is too bad, okay, please forgive me, because I'm trying my best to write it here. My laptop is very slow. X is less than equal to, I'm doing the negative part now, is less than equal to minus I by wait. Yeah. Minus I by root I by 2. And here is greater than minus root I plus 1 by 2. Okay? These are the two places and it's uniform, right? So the probability will add up. Iska probability will turn out to be, so therefore iska probability will turn out to be root I plus 1 minus root I by 2, and iska probability will turn out to be the same. Okay, because it's symmetric. So therefore the entire probability will turn out to be Pi is equal to root I minus root I. So it's same as, if you rationalize it, it will be 1 by root I plus 1. Okay. So both may be same. Just calculate it now for each one of those values. So, but let's do the general problem, okay? Let's do the general problem that where is the function fx is equal to root x plus 1 minus root x is maximized. Is maximized or minimized? What is the solution? What is the question? Maximized. Okay. Now here is a given condition. Understand that I plus 1 must be less than equal to 4. Okay. So I is less than equal to 3. Understand that this is an increasing function. Decreasing, sorry. It's a decreasing function because with the increase of I, root I plus this will increase and this will decrease. So therefore, Pi is the largest for I. Now I is actually greater than equal to 0. Therefore, for I is equal to, is it coming out to be 0? Have I done something wrong or is it fine? Is it 0, guys? Is 0? Lovely. So yeah, it's increasing, therefore it's decreasing, and therefore for I is equal to 0, it's coming out to be the maximum by normal logic. Okay? All of you understood it, guys? Bhushan, Kartikya and others, did you understand? I don't know who is Abhinav, Kartikya, did you understand? Good. Very easy problems, guys. If you practice enough well, I think this ISI PSA is really easy for you. Make sure you can gather as many marks in ISI PSA. Very basic. Okay, let's do the 21st problem. In a simulation experiment, two independent observations x1, x2 are generated from points show mean 0, 1. Okay. Perfect. Let's check it out now. X1 and x2 generated from point show means 1. Sorry. And the experiment is said to be successful if x1 plus x2 is odd. Very good. Lovely. Experiment is said to be successful if x1 plus x2 is odd. What is the expected value of the number of experiments required to obtain the first success? Okay. Tell me, it's a very easy problem. Which one I will be revising, Kartikya? Probability revision is done, Kartikya. We will start revising statistics from next day. You must see the recording, Kartikya. See the probability revision. We have been doing probability revision for a long time. Yeah.
I did x1 plus x2 follows point show. Then I've calculated when x1 plus x2 will be odd. After calculating, then what is the expected number of experiments required to obtain the first success?
So geometric, right?
Geometric P. So expectation of
very simple.
1 by P.
Lovely. So yeah, very simple, guys. Very simple. So yeah, you can understand it from here that x1 is point show, so x1 plus x2 is point show. What point show 2 hoga, right? x1 is point show lambda 1, x2 is point show lambda 2, so x1 plus x2 is for the point show 2. So x1 plus x2 is odd. A probability of x1 plus x2 is odd is what? Is same as, bolo,
1 minus e to the power minus 4 by 2.
Wait, how do you find it out?
I did it z equal to, sorry, x1 plus x2 I took it as z, okay. Then z equal to 1 to infinity, 2 to the power z by z factorial, e to the power minus 2.
Perfect. So she just expanded it. Okay, perfect. Thank you. So summation of probability of z equal to z. So z is equal to odd. So let's understand it. So it's, what is the Poinsot form? It's e to the power minus 2 e to the power minus lambda 2 to the power z by z factorial, right? So understand it's equal to z is equal to odd, right? So how do you find it out? So e to the power minus 2 to bahar aa gaya. So it's 2 to the power odd. So it's 2 to the power odd factorial stuff. So how do you find out, guys? Do you know the result?
2 to the power 2 cube by 3 factorial plus 2 to the power 5 by 5 factorial plus dot dot dot. Then this is actually e to the power 2 minus e to the power minus 2 by 2.
Yeah.
So it is easily done.
Exactly. So if you find out e to the power x, e to the power x ka expansion is what? x1 plus x by x square plus by 2 factorial plus x cube by 3 factorial plus dot dot. E to the power minus x is what? 1 minus x plus x square by 2 factorial minus x cube by 3 factorial. So if you just subtract or add it, you can get to see that the odd powers are important. So you can understand how to get the odd powers. E to the power x minus e to the power minus x. So you get that it's twice by 2 करोगे तो आ जाएगा x by 1 factorial plus x cube by 3 factorial ऐसा using the Taylor expansion. So you just use this result over here and you get. See guys, you can forget this result, okay? You can forget this result, it's totally fine. But what you need to do, then you have to take ideas from the options to understand why that like weird term of e to the power 2 and e to the power minus 2 are given, okay? Think about this in that aspect. When you have forgotten the result, okay? That's how that's where options are really important. Okay, so you get e to the power minus 2 into e to the power 2 minus e to the power minus 2 by 2, right? Right? Is it true? So, is it correct? Have I done something wrong? Okay, no. So this is a P, right? This is a P. And understand that an experiment is successful with probability P. So you have to do it every single time. Okay. Therefore, experiment we have to do it every single time. Okay. Now, how to write it mathematically over this? Okay, how to write it mathematically? Z given x1 comma x2 follows Bernoulli probability x1 plus x2 is equal to odd. This is small x1, small x2. ठीक है? This is the idea. You can also write that probability z given x1 plus x2 is equal to x follows Bernoulli probability. No, it will be actually x1 plus x2. Look at this. Okay. x1 plus x2 is equal to x1 plus x2. Is it right? Is it right? Yeah, it is right. Perfect. This is the idea. You should write like this, and then you can use conditional probability. Okay, this is the right way to write the problem. Okay, perfect, perfect. Let's move on to the next problem, guys. Now, um, okay. A shopkeeper has 12 bulbs out 27. 27. Okay, okay, okay. Okay, I will do 27 after this. Okay, I will do 27 after this. A shopkeeper has 12 bulbs, out of which 3 are. Is paper 27, right, Sneha? This paper is 27, right? So a shopkeeper has 12 bulbs, out of which 3 are defective. She sells the bulbs by selecting them at random, one at a time. What is the probability the 7th bulb sold is the last defective one? Okay, interesting. A shopkeeper has 12 bulbs, out of which 3 are defective. She sells the bulbs by selecting them at random, one at a time. What is the probability that the 7th bulb sold is the last defective one? Okay, how will you proceed this, guys? Tell me. Any ideas?
Until sixth trial, there has to be 2 defectives, and out of 9 non-defectives, there has to be
Bolo?
there has to be 4. He is selecting bulbs now. So among 6 bulbs that he selected first, out of those 6 bulbs, there has to be 2 defective and 4 non-defective, right?
She sells the bulbs as one random. Yeah.
So 9C4 into 3C2 divided by 12C6. This is until 6th. Now we are left with only 1 defective and 5 non-defective. So probability of the last defective will be 1 by 6, and then it is done.
Okay, Bhushan is saying it's negative binomial. So, any changes in the argument? 12 bulbs, each of which 3 are defective. She sells the bulbs by selecting them at random. Negative binomial? Do you think, Sneha, it's negative binomial?
I did it by simple name definition or classical probability. It is done by classical probability simply. So I'm not involved in any distribution. I think it can be done with negative binomial.
Okay, so Bhushan, tell me how I will do it in both the ways. So shopkeeper has 12 bulbs, out of which 3 are defective. So she's selecting them at one at random. What is the probability the 7th bulb he sold is last defective one? The 7th bulb. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sorry. So it's telling that there must be D here, and there are 3 defectives. So the previous 2 defectives must be here, right? So how we can arrange that? How we can arrange that?
3 choose 2 into 9, choose 4 by 12, choose 6. 3C2 into 9C4 divided by 12C6. And for the last defective, that is in the 7th place, that is into 1 by 6. Only 1 defective is left and 6 bulbs are left.
Okay. So okay, so you're doing it using normal, and in fact it's equally like, is it equally likely? No, it's not equally likely. It's not equally likely. So what you will do is that we will okay, it's not equally likely, so therefore we will do by factorial. So we will take all the 7 bulbs together, okay, in that sense, and take it in a certain way. Okay, we will just put all the 7 bulbs together. So how much? Okay, so that person is taking out all the 7 bulbs together. So do you think the rest of do you think that the numbers after 8 will matter? Will it matter? It will of course matter. Yeah, it will matter. Because the defective items can be in that side too. In the 8th place too. So नीचे is 12 factorial. ऊपर क्या होगा? All the possible arrangements such that the 7th bulb is on that place. So it's fixed over here. It's fixed over here. Okay. Now how many arrangements are possible? 2 before here. But understand that you have, out of these 3 defectives, you have to choose which one is defective. So it's 3 choose 1 over here. For this 3 choose 1. For the 7th place 3 choose 1. Which one is defective? Okay? Or maybe you can do it in a different way. How you can do it? You can choose it now. What you do? You first select the positions. The positions must be like, one of the positions is here and other positions must be in the 6th place. So 6 choose 2 for the positions. Okay, and this is fixed. The 7th place. 6 choose and this is fixed. Into 3 factorial. The corresponding arrangement among them. Okay. Into the rest of the 4 factorial, 8, 9, 10, 11, 5 factorial. No, wait. There's some, not 5 factorial. What are the left? I think left is 9 factorial. Okay, so it's also coming out 6 choose 2 by 12 choose 3. Check it out if it's coming out to be the same thing. Sneha, is it coming out to be the same thing? Is it correct? Bhushan, is it correct? So we are choosing okay, perfect. So let's check it out. 6 into, that is 15 into 6, 9 factorial, so it's like 12 into 11 into 10. So 15 into 6, it's 90. So it's 9 over here and 10 gets cancelled. So 3, and here also 3 gets 4 turns out here. So it's 3 by 44. 3 by 44. All of you understood it, guys?
I did it in a little different way.
बोलो कैसे किया तुमने? Until
6th shopkeeper is picking the bulbs. So until 6th, she would pick two defective bulbs. So 3C2 into 9C4
9C4 किस लिए?
divided by 12C6.
9C4 किस लिए?
9C4 for non-defectives. She is picking 6 bulbs. Now, out of 6 bulbs, there are 4 non-defectives and 2 defectives. So, I'm choosing
Okay, yeah.
those.
So
divided by 12C6.
3 choose 2 into 9 choose
4
by
12C6.
12.
This is until 6th. Now, 7th. 7th will be the last defective one, and I'm left with 6 bulbs. So, the probability of that will be 1 by 6. And rest.
And
Completed.
right. So now tell me why it's completed.
Yeah.
So why this is not mattering? Because the way she has counted, the way I have counted, I have considered all the tosses after 8 actually, but she has not considered after 8, like beyond 8. Why is it happening? Because in both our calculations, in her calculations, she has taken, okay, all the like bulbs in the first 7 cases. So therefore, the probability, the rest of the probability is actually happening, but it's actually turning out to be what is happening? Turning out to be 1. So can you tell me, the question is that, can you form this problem in a random variable format? That's my question to you. So we are using conditional distribution over here, conditional probability in a disguised format. So my question is to you is that how do we write this in a conditional probability format in terms of random variables? Tell me. Because this will connect you to the SRS WOR without replacement. Something is happening. How do we connect it to a random variable part? That's what I like. You must learn how to do with random variables this problem. Because these things are intuitive, we can easily count it, but there is some random variable stuff going on. Think about it. That's a very good exercise now. Bolo. How is the random variable stuff coming up? In this problem, how is the random variable stuff coming up? I told you that probability, give me a minute. I told you that probability you have done it using conditional probability, right? My question is to you is how to do how to express it in terms of random variables. That's the question. We are using some conditional probability problems out here. We are using conditional probability. So how we can use random variables? Tell me. Bolo, how we can do it in terms of random variables? How do you model SRSWR and SRSWR using random variables? SRSWR is very simple. It's a Bernoulli, right? SRSWR is Bernoulli or binomial rather. Right? SRSWR is binomial. But if you have done the statistics classes that we are doing, we have done already. How do we model SRSWR using probability? Using this is SRSWR, right? How do you model SRSWR? Bolo, how do you model SRSWR? Negative binomial is not the case over here, Bhushan, because there is the infinite tosses over here. How do we model SRSWR? We model it by hypergeometric. We model it by hypergeometric. So what is hypergeometric? Can someone tell me what is hypergeometric? In a population, there are n. In a population, there are n total population units. Out of the population units, there are some red and there are some like black and white. And now, given this, what is the probability of black balls or white balls that we are looking for? In say 5 in say the first 5 stuff. What is the probability of that? So this is the idea. Here, this is the idea. The first, so understand that X is hypergeometric. So hypergeometric is 5 parameters. Capital N, the total number of balls, which is 12 over here. Black ball is 3 say and white ball is 9, right? Now understand that if we are taking small n balls out of these 12 balls, then we have hypergeometric n, b, w, n. Okay, and probability of X is the number of say. If we take out n balls, X is the number of black balls. Then X follows hypergeometric this. Did you understand? N is equal to 2? No, in this case, no, n will not be equal to 2. In this case,
Equal to 6.
yeah, n is equal to 6. Perfect. So X follows hypergeometric. 12 balls, 3 black, W9, and n is equal to 6. We need to find probability X is equal to 2, right? Exactly, we need to find probability X is equal to 2. So this will give the initial probability what Sneha has given over here. This probability. And after this, we need to multiply it by 1 by 6. This cannot be done by hypergeometric. This can be done by hypergeometric. Yeah, it can be done by hypergeometric actually. Then X will change actually. X dash will be, then it will be X dash will be different. Hypergeometric. No, it will not be hyper. Oh yeah, it will be hypergeometric. X dash will be hypergeometric and X dash will be, n will be equal to 1 then. Okay, it's product of two hypergeometrics. After 6 tosses, it will be 6 balls will be taken out, and out of that, black will be only 1 and white will be 5 and N will be 1. So you just need to find probability x dash is equal to 1. So probability x is equal to 2 into probability x dash is equal to 1. In fact, the idea is that x dash given x actually follows this. X dash given x follows this hypergeometric. X is an x bar. So this is a problem. This is a nice sum, of course, but we need to understand the depth of it, okay? If we understand, just because we need to write it down in college, in the PSB part, if you write this down in terms of hypergeometric in PSB, they will give you a lot more credit, okay? Like if you do it in a normal probability way, because here we are joining it with a real life scenario with a random variable. Okay, random variable understanding is the most important part. So SRSWR, every problem in SRSWR you see, it's actually a conditional probability problem, which is actually a hypergeometric problem. Every SRSWR, okay. And in SRSWR estimation, you have to just estimate the hypergeometric parameters. That is the SRSWR. It's very simple, guys. Okay, so there is nothing to do more in SRSWR and SRSWR. SRSWR is actually उसका parameter estimation is equivalent to hypergeometric parameter estimation. ठीक है? Okay, let's do the last problem of today. That's Neha's doubt. It's 27th. So we have done till 22nd and 27th. Next day we will be starting the revision of statistics. Okay, Sneha and others, tell me one thing. Only 2 people are here though. Do you want the statistics from the entire beginning, or just want me to solve the problem solving aspect? Sneha and Bhushan.
I'm not sure if I've left any portion in revision. So if I have left some important concept or some important inequality and that comes up in exam, then
Okay, then I will give a brief revision maybe next day of the entire statistics syllabus.
That is okay.
And then we can start solving problems. Or maybe we can divide it in estimation and then problem solving for the next 2 days, and then testing hypothesis and problem solving in the next 2 days.
Okay. I want that PSB. I don't know how to write answers. That very well. Means how ISI demands the answer to be written.
Okay, sure. We can do that. Okay. So we'll do it in a way. No worries. PSB, I'm already always telling about PSB aspect. It's nothing very different. I will do it, of course. Like there's nothing very different of it, but I will do it. Okay, don't worry about that. They have some specific questions. Hello. So 27th problem is the following. X is normal mu comma sigma square. Y is equal to phi of x. What is the expectation of y? Okay. So here you have to use integration, okay? Here you have to use integration. So what you will do here is just write it down. Maybe you are thinking that we can use the idea that phi of standard normal is uniform 0, 1. Okay, that's a interesting way to do it. But if you do it in a different way, yeah, that's a way of doing it. But if you do it in this way, that let's do it. Let's transform it to a standard normal. Okay, first. So x minus mu by sigma is standard normal. So y is equal to phi of sigma z plus mu what is the expectation of y. Let's write it down just. Y ka density just find out. F of y, it's an increasing function, you can understand. It's nothing very different, it's actually very same. Phi of x. So do you remember the definition of how an increasing function, what is the PDF of an increasing function? Do you remember, Sneha and Bhushan? Let's do it in phi of x only. Do you remember how it is? So this is a Jacobian for one variable. How does Jacobian for one variable work? Don't you remember that? Think about the Jacobian. So let's say you know the Jacobian. Do you know the Jacobian of two variables? Sneha and Bhushan. So now convert it to one variable, 1 cross 1 ke liye. What will be it? So y is equal to phi of x. So x is equal to phi inverse of y. So this will be what? F of x here. So it will be in terms of phi inverse of small y. That is already done. Into 1 by f dash of, sorry, phi dash of x, which is phi inverse of y. Did you get this part? Is this part okay? Just check it out, guys, once. Sneha, please check it out. And Bhushan, please check it out. Perfect. If you check it out, now you know what is phi dash, that is standard normal. Right? And you can find it out now. The problematic part is you don't know the phi inverse, right? That's the problematic part. So now let's do it like this. So expectation of y is what? It's integration y phi of that. So that it's phi of small x okay, that's actually y is equal to phi of x into इसका एक्सपेक्टेशन क्या होगा into fx dx नॉर्मल जैसा होता है राइट phi x का expectation will be this simple right by the definition. Y is equal to this, then it will be fx dx. So phi of x is what? It's integration minus infinity to x e to the power minus the fx, actually f of t. Here it will be f of x dx, so it will be f of t dt. into f of x dx. That is the basic idea. Right? F of x dx. Is it right? Yeah, it's f of x dx. So now you just calculate it using normal way. You just use normal procedure. C to the power minus, how to do this? I think this can be done. I think this can be done using by parts. I think this can be done using by parts. Let's check it out.
F of t will be standard normal.
Oh yeah, f of t will be standard normal. You're right. Z. So it will be 1 by some constant. It will come up e to the power minus t square. Dt. Okay, tell me, it is the question is in terms of which format? In phi format, is it? Okay, it's in the phi format. So therefore, they are expecting us to do it in this format. Is it in terms of phi of something, right? Phi of some value. Okay. So they are asking us to, okay, now you understood what is the m. They are asking us to find it in terms of integration minus infinity to some constant f of t dt, just like this. They want us to find it in this format. Some constant f of u dt, f of u du maybe. So let's write it out over here. E to the power minus, what is that format? Some constant is of course there. Okay, I understood it now. It's x. Oh god. It's what was that? I think it was f of x minus mu by sigma square, right? Into x minus mu by sigma square dx. So
x minus mu square.
So I was thinking,
I have a doubt.
bolo.
We have learned that f of x CDF follows uniform 0, 1. Why can't we use it here?
Oh, because it's
When did we use this? Because I was totally confused. When
it's like this, right? So phi of z follows uniform 0, 1. So when we try to understand that phi of sigma z plus d क्या follow कर रहे हैं? So sigma z plus phi follows uniform mu comma sigma, like this. Mu comma sorry. Mu comma sorry no. it follows mu sigma, comma, mu plus 1 sigma. This follows. So you cannot use phi of over this. It's only on this. No, I'm so sorry. Like this is for, like here for phi sigma z plus mu, iska CDF in terms of this you have to find out. Then only you can find out the whole thing. Like you understand, this is not uniform 0 1. This is shifted uniform. उसके ऊपर ये हो रहा है. That is the main problem. Did you understand? Sneha. So here you do e to the power minus t square dt. So what I think personally, you need to transform it to. So first what we do is the following. We need to change x to something else.
Y has been given phi of x. What does that mean?
Phi is a function, right? Phi of t is a function. It's a cumulative distributive function of standard normal, right?
Yeah, that means y is phi of x. That is CDF of CDF. Then I cannot understand that. How will we write that? Y is equal to
so that's, we
x.
cannot write that, right? We don't have a closed form, but it is a function still. That's why the problem is coming up. That's why I need to use a special format. So we need to take in this format, right? So what we will do is the following. So let's take it together. E to the power minus half. Okay. It's x minus mu square plus t square plus sigma square t square by sigma square. Okay. dx dt है. So we will change it to something else. How we do that? That's the question. Okay. I did it using, just give me a minute. The integration is whole over x, the outer integration. It's like this. We do like this. T is going from x is going from give me a minute. Okay, I have arrived at the same problem again.
I have not understood the meaning of the question.
अच्छा
Y is
बोलो.
equal to phi of x, then they have said phi is the cumulative distribution of the standard normal variable, where x follows normal sigma square. So I have not understood what they are trying to ask.
Phi is a function, right? Phi is just a function, right? The capital Phi is just a function. It's just a CDF. A function of a random variable is defined. It's just like that. I will just take the solution, okay? It's not very hard, I'm sure. I think as far as I remember, there is a trick to do this. I think that trick is to do some byparts and compute the integral, okay? So the understanding is that we need to combine x and t. The basic idea is that we need to combine x and t. We need to combine x and t to get a single dz or something such that standard normal comes up here. I think we need to do that using this. Using this. If we take this to be z, if we take this whole thing to be z, okay, something will turn out. I mean, dz will turn out to be something, and dz dt will be turn out to be something in terms of z. So I think something will turn out, okay, z square actually. If we take this to z square, something interesting will turn out. And if we take it to be z square, yeah, the rest of the stuff will get cancelled actually, and this will turn out. I think this was the way I did it. There can be some other way, but the intuition that what Sneha is telling, that phi of that cannot be used here, the uniform wala. We have tried it. Okay. Okay. So I think I should end the class today here, and let's see you tomorrow. On yeah, tomorrow Shuhomda or maybe Uttarn will see you. Okay. I will give a solution of this soon. ठीक है? Bye.